In the previous videos, what we saw was the graphs of these functions. Capital A times sine of omega times x, capital A times cosine of omega times x. You really graph both of them in the same approach. From omega, you can get the period. Capital A tells you how high the graph is. In other words, the absolute value of A is actually the maximum of the graph. The graphs of these functions here, these are called sinusoidal graphs. And this theorem here is kind of telling us what we saw already, that if omega is positive, the period of each of these graphs is 2 pi over omega. The amplitude, which is how high the graph is, that's the absolute value of A. And even though we said that omega had to be non-zero, it's really enough to consider when omega is positive. Because if omega is negative, we just use the fact that sine is odd and cosine is even to handle that. And one period of the graph is called a cycle, and that occurs in the interval from 0 to 2 pi divided by omega. That's what we saw, that's how long it takes for one cycle to occur. In the interval from 0 to 2 pi over omega, 2 pi over omega, remember, is the period. And to graph it, remember what you have to do is you divide the period by 4 and you keep on adding that quotient to get the x values. It's just like what we did in our previous examples. So you divide the period by 4 to get the x values that you use to plot.